think. I will check it. So it's supposed to be broadcasting. So is that the actual Hangout link, or is that the YouTube live stream?
It started.
Live stream. Okay, it started.
Yep.
I think it lags behind the live Hangout a little bit, but yeah.
It started.
Okay, it started.
Yep.
That'll be really good to watch this.
Yeah, or at least keep your audio down. All right, so I think we can. I mean, people, like I said, people will be able to watch this later, so there's probably no reason not to get started. So I actually don't know a lot about you, Reza. So I don't know. Do you want to kind of start with introducing yourself? I knew you used to be at Oracle and all that, but if you want to just start off introducing yourself and then jump into the presentation, I think that would be great.
Right. Okay. First of all, thank you for having me. Second of all, I'm sorry that I have to do this virtually. I guess in this case, it sort of worked out since you haven't figured out a location yet. So maybe next time I'll try to drive out there. It's a little bit harder for my company because we only have a limited travel budget. So it's try to pick and choose the right thing to do. So a bit about me. I've been doing Java EE for a very long time, almost since it was started. I'm one of the people. I still have trouble finding somebody that started servlet before me. So I've been doing this for quite a while.
Mm-hmm.
For past 10 years or so, I've been heavily involved in the JCP in various Java EE JSRs, Java EE 5, Java EE 6, Java EE 7. Past 3 years or so, I've been at Oracle as an official evangelist for Java EE in the Glassfish and WebLogic team. I left that job, I guess, about a month ago, and really back into doing consulting, which frankly I enjoy more and definitely enjoy more than the last few months at Oracle for sure. So that's a bit about me. Let me go into the presentation now. Okay, so there you see my official title. I'm a senior architect with a company called Captech Consulting. It's actually a national consulting. I'll tell you a bit more about the consulting firm just to be fair. They are allowing me to do this talk after all. The title of this talk is pretty deliberate and actually embodies what I'm trying to accomplish in the talk. So obviously the main keyword in this talk is microservices. But the down-to-earth part is important. So I'm really not in the business of sort of cheerleading microservices on. I'm not a vendor, and my consulting company is not in the business of necessarily selling themselves as microservices experts. So honestly, we don't have a reason to oversell microservices. If for this particular talk, what I instead aim to do is give you sort of a pragmatic down-to-earth view of what microservices are and why it would be useful or perhaps not useful for most of us in the enterprise doing frankly ordinary but important things. The vanilla Java part is also important, and I guess it sort of follows the down-to-earth pattern. So what I will try to tell you is for practical microservices as it pertains to most of us, you actually don't need a very fancy tool set. Basically the standard Java APIs, more specifically the standard Java EE APIs, are actually pretty sufficient in writing reasonable microservices. So up there also is my Twitter handle and email address. If you have any questions or want to chat about any of this, definitely feel free to get in touch with me. Okay, so again, a little bit about my consulting company. We're essentially a U.S. national IT consulting firm. We don't necessarily sell ourselves as uber geek, super techie people. Definitely, technology is part of our core competency, but really honestly, our culture is far more important. We try to focus on client best interests, professionalism, kind of being a trusted advisor, people that you should have not much hesitation working with, because we in the end have your best interest at heart. Okay, so in the next 60 minutes or so, this is what I plan to cover, sort of your investment, to value your time investment. First and foremost, I'll try to explain what exactly microservices are, again from a practical standpoint. And after we do that, I guess the next important question we should answer for ourselves is, are microservices for you? Is it for the average enterprise developer or not? And in what circumstances do they actually make sense? And finally, I'll talk to you a bit about microservices and standard Java. How can you implement microservices using a fairly straightforward standard Java and Java EE API toolset? Okay, so let's start at the very beginning, and let's start with what exactly microservices are. And the very troubling part is in this very beginning. Microservices as a word is extremely vague, and honestly, the term is very confusing and perhaps not really all that appropriate. In fact, what I will tell you right away is that microservices in practice are not necessarily micro and not necessarily services. So that tells you a bit about sort of the strange naming going on in this microservices world. And all of this makes it, frankly, very hard for the average Joe blue-collar developer to understand these concepts, let alone implement them. And there's definitely a lot of marketing going on, and a lot of hidden or obvious commercial interests going on in this microservices sort of trend, if you will. If you really notice, it's been very heavily embraced by vendors and a certain class of consulting companies. That should be an indication to you right there that you need to be buyer beware. When somebody just takes and tries to oversell you on something, it's a reason to take a step back and think about whether you really need it or not. The other thing that really worries me about this entire microservices trend is, again, some of the naming and the way sort of this is being positioned. So in addition to the word microservices, the other word that's thrown in the mix is monolith. And really, just like microservices, this monolith word is very loaded. It basically makes you think that, okay, if you're doing this monolithic application thing, you must be doing something bad, and you really should be doing something differently. When in all reality, most of us that have been in this industry for a little bit of time know very well that things are not that cut and dry. Things are not that black and white. There's a lot of gray area and a lot of trade-offs. In fact, one of the messages that I will try to give you in this talk is monoliths are not necessarily all that bad. In fact, they might be the right thing to do for many applications. And of course, we'll try to see what those are. The other thing I will try to tell you is that microservices are not necessarily that new. The term is new, and frankly, I believe it's deliberately coined to be a new term. In all reality, we've seen aspects of these problems and attempts to solve them in many different ways. So starting from Unix to Corba to Jenny to RMI to EJB1 and 2 to COM and DCOM to OSGI and SOAP and ESB, really we're looking at different facets of the very same thing. In fact, what I will say, from the very start, is that I really believe that SOA and microservices have much more in common than they have differences. In fact, I really think that if somebody was really intellectually honest and wasn't interested in marketing concerns, The real name that they would have probably given microservices is simply SOA2 or son of SOA. So that will, I think, clue you into perhaps a lot of what I'll tell you next. So the next challenge we should tackle is what exactly are microservices then? We've sort of talked about how they're different from SOA and maybe not so different from SOA. What is actually a reasonable definition that you can sort of present in good conscience? And honestly, I struggled with this quite a bit. I read tomes and tomes of sort of the microservices material that's out there, and it took me a long time to cut through them to get to, if you will, the kernel of truth. And so the definition that you see on screen there is really the definition that I'm comfortable with. I think it's an honest viewpoint of what we're actually dealing with. So in my view, microservices are about decomposing larger, not necessarily very large, mind you, larger systems into smaller systems. Not necessarily very small, but it's smaller compared to the overall whole. And these smaller parts ought to be independently deployable. You ought to be able to deploy them independent of each other. If you've accomplished this goal, I think within reason we can say that you basically have accomplished the goal of microservices. So for those of you familiar with things like SOA, and in fact, all of the other predecessors that I talked about, you'll notice that this definition is not very, very different from the basic definition of SOA. Right. So the next question we should ask ourselves is then, what is different from SOA? What I'll try to tell you is what sort of the microservices, the most, I guess, ardent proponents of microservices say, and sort of my take on how I view that. The purists, microservices purists, first and foremost, will immediately distance themselves from SOAP and ESB. They'll say, okay, we're definitely not in the business of ESBs. We don't want centralized coordination and centralized transformation at all. SOAP is terrible. We don't want to use SOAP. Me personally, I have a more pragmatic view of this. I think there is a place for SOAP. There's nothing necessarily wrong with composing independently deployable smaller services using SOAP. I see nothing wrong with it if you have the correct use case. I never liked ESBs. I do think they're unnecessary and heavyweight. However, I also don't necessarily see anything wrong with using ESBs if you have the right use case for it. And frankly, I think the right use case for ESBs is very, very narrow. What microservices purists will wholeheartedly embrace is REST. They'll say, okay, microservices must be REST, or for the most part, it must be REST. And if you don't want to do REST and you want sort of more reliable communication mechanism between your services, then you ought to be using messaging. So in the Java EE world or in the Java world, this would likely mean something like JMS. I do agree with this. I do think if you're developing services, remote services today, REST is probably the natural choice for the most part. And I definitely like messaging. I definitely do think messaging is a good way of adding more reliability to your system if you need it. So these are good ideas. The purists will also take for granted things like automated testing, DevOps, and continuous delivery. They'll tell you that if you're doing microservices, you better be sort of masters at these things. Me personally, in the real world, I've seen very few enterprises that will say that they are masters of things like automated testing, DevOps, and continuous delivery. So if these are prerequisites to being doing microservices, I think we're in big trouble. Most people would not be able to do it. My view is that yes, these things are important. They're important even for monolithic applications. They're marginally more important for developing microservices, but they are only prerequisites. You only need to absolutely master these things if you are developing a certain type of microservice, and we'll see what that certain type of microservices are. In fact, it's the next line in my bullets. Basically, if you're developing very fine-grained microservices, these things become necessities. You absolutely need to get these things right. For the rest of us, folks that are not in the business of necessarily creating very fine-grained microservices, actually we don't. These are no more or less that important than in the monolithic world. They are important, but they're not absolutely essential necessarily. You don't have to get it absolutely right. The purists in microservices definitely do mean micro when they talk about microservices. In fact, what I will tell you is the microservices sort of purists are actually not talking about distributed systems anymore. What they are actually talking about is distributed objects. And frankly, this worries me quite a bit because I've seen distributed objects in practice before, and I am seeing them in practice now. Some people are taking this microservices stuff and creating distributed objects, and distributed objects are notoriously difficult. You don't want to get into the business of distributed objects unless you really, really need to. For me personally, I think microservices are about coarse-grained microservices, coarse-grained services, and actually subsystems. That's a key word for me. It's really about distributed subsystems, and that is where the majority of us will get value from the concepts of microservices. Okay, so with that sort of background in mind and sort of attempts to define what these things are, let's now talk about what is the value proposition. Why would you even want to do these things? So if you step back and think about it a second, what are the most important things? What are the things that sort of keep us up at night and make us worry as folks in IT? I'll tell you, these are these have been static, relatively stable concerns for many years for most of us, and these are meeting requirements first and foremost. Making sure that the thing that you are developing actually is generating value. That's a big headache for most of us. The other big headache is resourcing. Getting the right people, with the right skill set, and getting enough people to get the job done. And the reality is we're still under heavy pressure in IT to do less and less, to do more and more with less and less. So the resources are a very real concern for most of us. The other big concern is system stability. The thing that worries most senior developers is getting that call at 2 a.m. at night that says, okay, your system is down, you figure out what on earth is going on, and we really need to get this working. Similarly, getting things to production and reaching stable state, bug-free state in a production system. These are the three primary concerns for most engineers in the enterprise. The reality is that microservices won't necessarily help you with any of this. In fact, if you do it wrong, the microservices will actually hurt you. It will make these three things harder, not easier to implement. So the question is, then what is the value proposition of microservices? In my opinion, the most important value proposition actually has to do with a fourth concern for most of us, and that is maintenance of code, writing the longevity of code, being able to have systems that can be worked upon and kept maintainable for a long period of time. Because the reality is, most software only spends about 20% of its life in development mode and 80% of time in maintenance mode. Really, microservices helps with this issue of maintainability under certain circumstances. So let's let's talk about why this is. So the reality is that almost all software goes through entropy. What this means is that over a period of time, it becomes harder and harder to maintain a system because code quality gets worse and worse and worse. Time and again, one of the things that is proven out is that code quality gets worse the more people are working on a given piece of code, right? And there's various reasons for this. When you have a lot of people, they're not necessarily all that familiar with the system. If it's a very large system, they don't really have a lot of sort of ownership of the code, so they kind of just get things done and move on, with the thing that they need. In a very large system, it becomes oversight becomes a difficult function. Maintaining code quality becomes a difficult function. But you have to be reasonable as to how far you carry this argument. We can't, take this argument and say, okay, all systems should be single developer systems. That just isn't a practical way to think about things, as we'll see in just a second. In fact, in my experience, what I've seen is that if you have a bit of software and you have about 10 or 12 people working, 10 or 12 engineers working on that system, you actually can maintain pretty decent code quality. Anything more than that, it's probably a problem. If you have 20 people, 30 active developers working on a system, that system is probably unmaintainable. You won't be able to maintain that. I think as long as you don't have that type of system, you're really talking about anywhere between 10 and 12 engineers or less working on a system, it's not really that hard to maintain code quality. So really, when you are crossing that threshold and you're really reaching a stage where it's becoming difficult to maintain a system with this small team, that's when you really need to be thinking about microservices. That's where you really need to be thinking about breaking up the system into smaller independent parts, that are independent of each other and can be deployed independently of each other. Now, if you reach that point, the next question you'll need to ask yourself is, well, how on earth do you determine how to modularize? Right? Where do the module boundaries lie? And it doesn't matter, when you start thinking about this process. It doesn't matter if you already have a monolith and you need to decompose it, or if you when you're starting to develop the system, you're already going to see that this is going to be a large system, and you need to have modularity in mind from the start. Either way, it's very difficult to determine how to decompose these systems. So in my experience, there's two different ways that natural decomposition of systems occur, and that has to do with business and system needs. So let's talk about business needs first. Business needs actually determine subsystem boundaries when a particular set of users perform a specific function. Right? So typically, these will be people segmented that are using your application that are segmented by, let's say, department or business role. Right? That's a good indicator that bit of code, actually, that bit of the system should probably be its own distinct subsystem and has nothing to do with the others. So let me give you an example from my own experiences. I spent quite a bit of time working in the insurance industry. So if you take a look at your typical insurance company and you think about their systems, the entirety of the systems are probably something in the order of multi-million lines of code, right? nobody in their right mind, actually develops that type of system as one monolithic application that you deploy once. I've never seen it happen. I've seen multiple insurance companies, design completely different systems. So what does actually happen? If you look at insurance, insurance has different functions. So you have, for example, the point of sale system. The insurance agent that you go to say, hey, can you sell me insurance? And this person will open up some kind of terminal screen and take down a bunch of information. Your name, your address, your dependents, your home address, what assets you have, and the like. That's a point of sale system. So that data actually goes in the backend and goes to another distinct group of people. And these people are essentially pre-underwriters, and their job is basically to see, okay, did we get the adequate data, all the data that we need from the point of sale system? And if we didn't, we sort of tell the insurance agent, hey, this is the stuff that's missing. You need to gather this further information from this particular potentially insured. And then what these people do is they'll look up a bunch of information about you that you probably don't even know exists. Starting from your credit history to your health to your criminal background, what addresses did you live at, and all kinds of, frankly, pretty scary stuff that insurance companies can gather about you. And then after all this information is gathered, this data goes to another group of people called underwriters, and their job is to basically take all this information and use some automated algorithms as well as their own experiences to determine how much they can insure you for. And after that, insurance goes into many other distinct group of insurance business users, like account management, billing, reporting, archival, policy disbursement, and the like. And what typically happens is each of these distinct set of users use a distinct system, right? They use a distinct subsystem. And these subsystems are actually remote from each other, and they share data. In the end, they all share insured information. They all share policy information, but they're decoupled from each other. They may share some data, but often, these are distinct subsystems developed often by distinct teams, distinct development teams. Similarly, system needs will sometimes make decomposition lines fairly obvious. So one example I already gave you is reporting. Reporting, because of its nature, is technologically very different from the rest of the systems you'll typically develop. In fact, most reporting databases will often be different from your online transaction processing systems, and that's why in most cases reporting is probably a good idea to develop as its own distinct subsystem. So the next question you should ask yourself is, okay, if we all agree that modularity is important, to maintain code maintenance and the like, then why do we need to make this distributed? Couldn't we just develop local modules in sort of OSGI style, or even just as plain jar files? There's a couple of different problems with that. The biggest problem is that when you do this type of modularity, it's often harder to make things independently deployable. And it's also very easy to sort of break module boundaries and to create all kinds of dependencies that you didn't intend. And at the end, what happens is, these systems become tightly coupled, although you didn't intend it that way. So that's why distributed systems, in my view, actually does make sense. Because when you have a remote boundary, between subsystems, you're essentially forced into discipline of not inadvertently making sort of these mistakes of inadvertently creating coupling, okay, between systems. So there's some other arguments that I don't necessarily agree with, but I will mention. In terms of how microservices are typically sold. So one argument that's often made is that microservices are supposedly easier to scale. So the argument goes something like this. So if you take a bit of software and you break it up into multiple units, then it follows that, okay, you can assign more hardware to these multiple units, and hence, if you have more hardware, then you should have more performance. The weakness in this argument is that you actually don't need to decouple your system in order to apply more hardware to it, because we've long had this technique called horizontal scaling. So, in other words, simply make another copy of your software, throw it on another machine, and put it in front of a hardware load balancer or a software load balancer. And there you have it. You can scale pretty reasonably that way, simply by doing horizontal scaling, without necessarily needing to break up your software into smaller units. And the reality is that these horizontally scaled systems do scale, right? I mean, they scale extremely well, and most certainly good enough for your average enterprise use case. But you can't infinitely scale horizontally, right? So if you are, let's say, a Google or an Amazon or a Netflix, and you really have a very, very large scaling requirement, so you have millions of users, let's say, thousands and upon thousands of concurrent users, horizontal scaling actually will not be good enough for you, right? You will need to think about really modularizing, right? But few of us are going to reach that scale, right? So it's sort of violating KISS principles if you're trying to do things that meets the scalability requirements of an internet scale business, and you're really not an internet scale business to begin with. The other selling point for sort of microservices is that it's supposedly going to cause a new dawn of polyglot programming. We're going to have all these little components composing our overall system, and each of these components will be written in a different technology set. And the idea is that this is supposed to be a good thing. The reality, though, is that we've dealt with polyglot programming for many, many years now. Right? So this idea of that you ought to be polyglot has been around for a long time. The reality in most enterprises are not that polyglot. At best, they maybe have 3 major technologies across the enterprise, let alone in a single system. And there's good reasons for that. It has nothing to do with technology. It has to do with technology management. Right? When you have a team working on a bit of software, it becomes very difficult if that team cannot interoperate. One person cannot pick up another person's work very easily, and they cannot technologically communicate with each other very well if they don't share a common skill set. Right? And it becomes also very difficult if you have some turnover. Imagine a bit of code written in some obscure language, and that nobody really knows, and suddenly you have that individual leave the company. Well, now you have 2 problems. You have a system that you don't know much about that you need to maintain, and you need to learn a new technology to learn this. So I don't necessarily buy into the polyglot programming argument that much. I think yes, it's a benefit, but how much of a practical benefit for most of us, I don't know. Greater agility. This one is actually true. In fact, I believe this is one of the principal reasons why some of the microservices adopters are adopting microservices. So the basic idea here is that the smaller your unit of deployment, the faster it is to deploy it, right? Because you'll need to run less integration and unit tests, right? It's only a small, limited set of functionality, and the deployment unit should be relatively small and fast to deploy. This argument does have merit, but it has not as much merit as you might think. So when you go into the world of distributed objects, the reality is making a single deployment is not so simple. It's not just a matter of testing that just that one component anymore, because just testing that component only will get you unit tests. In reality, when you're talking about very fine-grained microservices, the reality of what happens is that you not only need to deploy and test just that one small component, you have to figure out what are all of the components that are dependent upon that bit of software, and you've got to test all of those as well. So it's not as compelling as you might think. Okay, so it gives you a bit of agility, but there is a point of diminishing returns that you have to be conscious about. So in this slide, I have a little circle here, and I've circled a concept called bounded context, and it belongs in the domain. It belongs in an architectural practice called domain-driven design. And I happen to actually be a proponent of domain-driven design. I've used domain-driven design for almost 10 years now. And believe it or not, all of what I talked about is specifically as to how you go about decomposing systems according to business needs. Well, guess what? We've been doing that in domain-driven design for 10 years. We've known about this concept of bounded context for 10 years. So it's a well-established, proven-out concept. It's not, something that is unproven. And I think that's the key to really developing effective microservices. And bounded contexts are definitely all about subsystems. They are not about distributed objects at all. Okay, so we talked about sort of the promise of microservices. We should now talk about what the downsides of this thing are. And none of these downsides are actually very old at all. Right? These are very new at all. These are well-known downsides to distributed computing that we have known for a very, very long time. And in reality, none of this has actually changed. Much of this has remained exactly the same as it has been for many years. So let's talk about what these things are. The reality of distributed systems they are inherently more complex to administer, deploy, and monitor. This is simple common sense. What is easier to administer, deploy, and monitor? Just one single system running on a single server, or hundreds or perhaps dozens of services that are independently deployable across your network? The answer is very simple. It is definitely easier to administer, deploy, and monitor a single system. Right? Whenever you're talking about distributed systems, all of these things become harder. It also becomes harder not just in terms of the administration phase, but also during the development phase as well. Distributed systems are harder to test, right? Because as I mentioned before, it's not just a matter of testing your own component. You have to test all of the components that depend upon you and all of the components that you depend upon. Whenever something breaks, you don't know if it's your component that has caused the bug, or if it's another service that you are invoking, or another service that is invoked by the service you are invoking. So things like debugging and diagnostic become very, very difficult in distributed systems. Similarly, reliability becomes difficult. In a single monolithic system, you can easily enforce reliability and consistency by local transactions. Right? So if you have a unit of work and the unit of work is within one transaction, you succeed or fail. Right? Atomicity is very easy to guarantee in one monolithic system. Well, now, whenever you're talking about a distributed system, well, you're going to introduce essentially a remoting boundary, okay, across your transaction. Well, transactions don't work across remote boundaries. The only way they work is distributed transactions, and distributed transactions are extremely difficult to implement, and they are also very slow, right? So. Really, in practical terms, when you're talking about developing REST-based distributed systems, it becomes very difficult to maintain reliability and consistency, especially if you're talking about very, very fine-grained systems that have to interoperate with each other to essentially implement a logical transaction. Code duplication is another one, right? So whenever you're talking about decomposing systems, you will always wind up with some code duplication. And the code duplication gets worse and worse the smaller your unit of deployment gets. Right? The next one should also be obvious, right? You need higher skill and automation requirements to develop for development and operations of distributed systems as compared to monolithic applications. The other two bullet points that I have is actually something I want you to actually Google in your own time. I'll give you hints on this. And this all goes down to the stuff that we talked about previously. One is called the distributed big ball mod. So one argument you'll hear from the microservices proponents is that if you're developing a monolith, it'll eventually become a big ball of mud. Well, that's a fair argument as long as what we talked about. When you're talking about very, very large systems, yes, you will have a big ball of mud. The reality, though, is if you do microservices wrong, you'll wind up with not just a big ball of mud, but a distributed big ball of mud. Right? So, if you think a big ball of mud is hard to maintain, a distributed big ball of mud is even worse. Right? So you really need to watch out for not to get into this distributed big ball of mud. And if you are talking about distributed objects, you will almost certainly be there. You'll almost certainly get yourself there. The other sort of phrase I would like you to look up is something called the fallacies of distributed computing, and it's actually came out of Sun Microsystems some many years ago. If you remember, Sun Microsystems' motto was the network is a computer. So these guys were obviously big fans of distributed computing. But at the same token, they also warned us about what the downsides of distributed computing are. So I'll tell you a few of them. These are that the network is slow. Okay, so whenever you introduce a network call, you will incur bandwidth penalties, you will incur serialization penalties, and you will incur at the end either memory or CPU penalties, okay, as compared to a local call. The network is unreliable. Okay, whenever you are talking about a distributed system, you can have failure at either a machine level or at the network level. These failures do not occur when you're dealing with systems that are not distributed. The network is unsecure. Okay, whenever you're talking about adding a network, you're increasing your security risk as well. The network is not homogeneous. Okay, meaning you may not even know who manages a particular subnet where your service that you depend upon might belong, or somebody that's calling you. It makes management of these systems significantly more difficult. Okay. So what do I think is the bottom line? I honestly think this is the bottom line. So I really think that a majority of systems are probably fine as monoliths. I've lived through sort of the microservices hype, and I can tell you that I don't dislike SOA. I think there's a lot of legitimate points to SOA. But I will also tell you that in the end, I didn't develop a lot of SOA systems. I wound up developing a lot of successful monoliths. And I think that will continue to be true. I think most of us won't necessarily be developing microservices systems. We will be continue to develop successful monoliths for most of us. And a majority of systems that actually need the concept of microservices, we talked about some of those cases, those would actually not be microservices in the purest sense. I think those will be hybrids. They will look probably a lot like classical SOA, basically large-grained subsystems talking to each other across the network. Or they will be another variant that I have seen, and that is when people have a monolith and they're clearly dealing with the monolithic problems, and they start to break up those monoliths. And the way you naturally do that is you identify chunks of the monolith that you can break off. These tend to be at the peripheries of a monolithic system. So what you wind up with in that scenario is sort of a big monolith in the middle and a lot of supporting microservices as satellites, so sort of a hub and spoke model. And over time, what you will try to accomplish is grow those satellites and shrink the monolith, so that in the end you do have basically something that looks like coarse-grained, large-grained subsystems communicating with each other. A few practical enterprise systems I will say that I think actually needs to achieve this so-called microservices nirvana. In other words, writing very small fine-grained microservices. Okay, so there's the phrase that I think is very valid, that a picture says 1,000 words. I think most of us process images much better than we process perhaps text or verbal cues. So next, I'll show you a picture. If none of the core of what I just told you, specifically in the bottom line section, landed, I think this picture will land. So let's take a look at the picture. Take a look at this picture for a second. Some of you might know what this picture is, but for those of you who don't, I will tell you what this is. This is the only known system diagram for Netflix. Okay, and Netflix is one of the poster childs for microservices. Whenever people talk about microservices, they use Netflix as the reference example. I honestly don't think most of us in the enterprise want to deal with a single logical system that looks like this. I think this is not microservices nirvana. I think for most of us, if we try to write systems that look like this, it would probably be more like microservices hell. So don't get me wrong. I think in the enterprise, we do see diagrams like these. But we see diagrams like these, for example, when we look at our database schema ER diagram, or if we try to create a class diagram of our entire system, it would probably look something like this. So we do deal with this type of complexity. The problem here is that the level of complexity that we deal with has been escalated to the level of systems. So these are essentially have become distributed objects that are communicating with each other. I really don't think most of us want to be in this world. Okay, so let's talk a bit about. Hopefully, at this point, you're convinced that what you really need if you are to venture in the microservices world is more coarse-grained systems. So let's talk about, if that's the case, then what is it that vanilla Java EE offers you? And the reality is it actually offers quite a bit, and it's quite sufficient in terms of developing coarse-grained subsystems, and to get the most basic benefits of what microservices has to offer. So let's take a look at the Java EE APIs for a second. So first and foremost, it should be fairly clear that when you are developing microservices, what you need is a remoting protocol. And actually, because Java EE has roots in distributed systems, we're actually very feature-rich with this regard. So we have support for REST in terms of JAX-RS. We have support for messaging via JMS. We have support for WebSocket. We even have support for SOAP via JAX-WS. And if you even want to use it, we have support for Corba and RMI. So you have a whole bunch of remoting protocols that you can use. We also, the other thing you'll need is some kind of serialization and deserialization mechanism. Again, we have a whole bunch of range of choices built right into the platform. You don't need any external libraries or anything to work with it. So you first and foremost have support for JSON, right, which is probably what you'll be doing for the most part when you're developing REST-based microservices. You also have support for XML. We have an excellent binding API called JAX-B, okay, that you can use for XML. You also have support for things like native Java serialization if you want to use it. Right? So that's also a legitimate enough choice, okay, for developing microservices. We also have support for things like bean validation, which become very important, especially when you're developing services and you want to apply contract-driven design at your services. We also have a bunch of services to help us develop the rest of our microservices platform. So things like transactions and security and asynchronous processing and scheduling, those come with EJB3. We have a very good dependency injection solution in terms of CDI. We have a very good API to talk to the database, whether it's relational or non-relational, with JPA. Clearly, as I've communicated to you, hopefully, whenever you're dealing with coarse-grained services, you will have a UI. Okay, that UI could be in AngularJS, which would be fine. You can do that with JAX-RS. You can use JAX-RS as your REST endpoint and have AngularJS as your UI. If you don't want to do that, you can use JSF. I'm a fan of JSF. I've used it successfully for many years. It's a very nice, polished UI framework for developing server-side UIs. In addition to that, all of this, other than the API level, you have a bunch of features at the runtime level that Java EE also provides. Right? So these range from things like administration, monitoring and management, high availability for doing horizontal scaling. You have ways of securing your application as well as securing your runtime. You have various resource management APIs, starting from pooling to connection management to object pooling if you need it. So a whole bunch of APIs that are important for developing monolithic applications and actually become even more important while developing microservices, as we've seen. Okay. So without further ado, let me show you a simple example of a microservice. Okay, so the code example that I'll show you is actually available on GitHub. So you can actually go and download this code. There's, I hope, relatively reasonable instructions on how you can set up this code yourself. Okay, so you can take a look at how this code actually looks like. So let me jump to the demo now. So I'm using NetBeans for my demo. Okay, and you can use any ID. The code is actually Maven. Right, it's just two Maven projects, so you can use any old ID that you want. You'll notice that I have two different applications. One is called Cargo Tracker, and the other is called Pathfinder. These are two distinct applications of one larger system. Okay, so I'm going to go ahead and deploy Pathfinder first. Okay, so I'll deploy it for you. So you run. Okay, you'll notice that the application deployed and ran. Let's take a look at the Glassfish console. You'll notice that this application deployed in just over a second, okay, 1200 milliseconds. Why is this? So let's take a look at what's going on under the hood. So if you look at the Pathfinder target application, here's the var that was deployed. Take a look at the size of this var. It's 11 kilobytes. Okay, so that's why this was deployed so quickly. This actually is a microservice. The Pathfinder application, as you'll see, is definitely a microservice. Cargo Tracker, on the other hand, is a monolith. Let's run this guy. Okay, so this Cargo Tracker Right? As you'll see in a second, this is a fairly substantial application. It's about 20,000 lines of code, in fact. Okay, but take a look at what the deployment time for this was. Okay, it's about 50 seconds. Okay, not a terribly long time. It's essentially under a minute. Okay, so why is that? So let's take a look at the reasons for that. So let's go back and take a look at Cargo Tracker this time. Okay, and what you'll notice is that this file is just 5 megabytes. Okay, so remember this is 20,000 lines of application, 20,000 line application, basically compiled down to a 5 megabyte deployment file. Okay, why is this? This is because we're talking about Java EE. We're talking about plain Java. Right? All of the APIs that you require are already in the Glassfish runtime. So your deployment unit is very, very small. And actually, in the almost 10 years that I've developed Java EE applications, rarely have I seen an application, especially when you're talking about a modern runtime like JBoss or Glassfish or TomEE, that deploys in more than a few minutes. Right? These are very, very large applications, that are being developed by, roughly 10 concurrent developers. Yet they manage to deploy in a matter of minutes, right? Not many minutes, not half hour, not hours, in a matter of minutes. So this is one of the reason I wanted to show you this is to understand, some of the arguments and the hype that I see. So when people talk about microservices, they kind of pretend that okay, a monolith is so horrible that it takes hours to deploy, and I've literally seen some of this in the microservices literature. And I think the reason they're saying these things is because they're not actually using Java EE. They're using some other technology that actually doesn't deploy as fast, because they do a whole bunch of things in order to accomplish their deployment. So now let's take a look at the Cargo Tracker application. I'll show you real quick what this application is. It tracks cargo around the world. So there's a tracking interface. Okay, and that'll tell you, okay, this is where your cargo is. This is its current state. It's in New York, and this is where it is at the moment. There's a mobile interface. Okay, a mobile-ready interface. It's basically to enter cargo information. Whenever you enter this information, it actually changes data in the backend. Okay. It's not terribly that important actually to understand all this. There's a dashboard. Okay, there's various bits of functionality like booking. There's also a live map. I'll show you that real quick. Okay, this shows you what the current location of each of this registered cargo is, and so on. So this is a relatively substantial application. The part that I want to show you is actually booking a new cargo. So let's go ahead and do that. So I'll say it's going from New York to Tokyo, and let's say that it is supposed to arrive in July or 22nd. Okay, that gives us 67 days with the delivery, as you can see. I'll book the cargo. Okay, here's my new cargo. Okay, it's going from New York to Tokyo. It's not routed yet, as you can see. It's under the not routed table. To route it, I need to click on this little globe. Okay, so I'll go ahead and route this cargo. When I route this cargo, you'll see that I'm given a bunch of options, okay, of how to get from New York to Tokyo. I'll select one of these guys. Now my cargo is routed. Okay, so let me tell you a bit about what happened here. By and large, this application, as you saw, is mostly a CRUD application. Right? It's all about taking data from a database, doing a little bit of massaging, and then showing some data on screen. The big difference, though, is this routing business. Right? So to figure out how do you go from point A to B. That actually is a significantly different bit of code from the rest of my system. Right? there's a complex algorithm that determines, how do you take an origin and a destination and go from point A to point B. That actually is not part of the cargo tracker monolith. Why is that? Well, the reason is, because it's substantially different and algorithmically different, it's a fundamentally different problem set. Two things will occur. One is that you probably need a specialized team of people working on this, working on just that bit of code, right? That code, the velocity of the pathfinder operation, how do you go from point A to point B, probably changes at a greater pace than the rest of my cargo tracker monolithic application that is relatively CRUD. Okay, so this is a case where I do want to break out the cargo tracker and pathfinder bits of code into two different services. Okay, I'll show you how the service invocation is happening. I'll let you take a look at most of this code by yourself. This is the code that actually makes the routing happen. Okay, so if you look at this method, there is a method called fetch routes for specification, and it takes a routing specification as an argument. Okay, the routing specification is the origin, the destination, and the arrival deadline. Okay, and how is this determined? Well, it's not determined, and remember, this bit of code is in cargo tracker. Okay, this actually does not happen locally over here. What we wound up doing is actually making a REST call. You see, it says graph traversal service resource query parameter origin destination, and make a GET request, okay, of type JSON, right? And what we end up getting is a list of transit paths. Okay, this is actually a remote invocation, right? So this is how the remote invocation is set up. Right? So there's a JAX-RS client, okay, REST client that takes a graph traversal URL as an argument. So if you look at my code, in my configuration files, I actually have a URL configured. Okay, and in this case, the URL actually points to the same local host, but it could be a different host altogether. It could be a different logical machine hosting the service. Okay, and the service is actually the Pathfinder service. Okay. So I'll let you take a look at this code and run it and take a look at what this is. But none of this is super complex. Okay, it's just using a very simple tool set to accomplish the basic benefits of what microservices are supposed to give you. Okay. So before I finish this talk, there are some buzzwords that I need to sort of cover. Okay, otherwise. So I wouldn't be doing, I wouldn't be being fair to the people out there heavily selling microservices. Okay, so let's talk about some of these buzzwords, and I'll sort of give you my take on these. So the first set of buzzwords that you'll encounter in the microservices sort of terminology is fat jars or containerless microframeworks. And some examples of these are Wildfly Swarm, Payara Micro, Cumuluzi, Tommy E Embedded, Spring Boot, and the like. What these things do is instead of deploying your application to an application server, what you do in this case is that you actually ship your application server and everything that you need to run your application inside of a jar file. And you deploy this jar file and you run this jar file. Well, what's the problem with this, and what are the benefits? The benefits, frankly, are, the big benefits that I see in terms of fat jars or microservices framework, these containerless frameworks, is that you skip the installation and configuration step. Okay, so it's useful especially for PaaS environments where you don't have a lot of control over your runtime. That's where I really see these containerless frameworks being valuable. The downsides of them, there's actually several. The biggest downside is that deployment size. Right. So when you saw my Java E application, my deployment size for my application is like in the neighborhood of megabytes, right? Typically your typical, that's your typical Java EE application. It's hardly ever exceeds, let's say, 10 megabytes or so. And when you're developing fat jars, the bare minimum that you'll be dealing with is at least 20 to 30 megabytes. And the more and more functionality you add, the greater, the bigger your microservice becomes, the more coarse-grained it becomes, the more it becomes more like a subsystem. Well, guess what? You'll be adding more and more fat to your jars. You'll probably be at some point dealing with 100 megabyte, 100 megabyte deployments. And guess what? That's the size of a typical Java EE application server, like Glassfish. Why would you want to do that? Why would you want to increase your deployment size, increase your deployment time, and increase your deployment complexity factor? It doesn't make a lot of sense to me. It also makes it very difficult to administer, right? So as an administrator, you want the infrastructure to be separated from the code. Right? You want to know, okay, this is the application server version that is running. I know how to manage and monitor this. You don't want these things to change overnight. When you're developing this becomes harder to manage and monitor for your typical operations folks. Another sort of buzzwordy technology that you'll see in the microservices realm is Docker. Now, I actually like Docker. The reason I like Docker is actually it commoditizes something that really needed to be commoditized, namely virtualization. Right? So if you're talking about VMware, for example, VMware is significantly expensive. When you're talking about creating a VMware image, a VMware image is very hard to deploy. It's typically in the neighborhood of gigabytes. A typical deployment image. Docker, on the other hand, is cheap or free, and the Docker deployments are usually run somewhere in the neighborhood of 30 megabytes to, let's say, up to a gig. Okay, so this is a good thing. Okay, it's more lightweight than virtualization. The problem is, the religious elements of this. So when you're talking about these folks that are talking about Docker and microservices, what they are suggesting is that your deployment unit shouldn't be the WAR file. Your deployment unit should become your Docker image. Well, again, it has the same problems as these fat jars and things, right? Why would you want to deploy your entire operating system, literally close to a gigabyte deployment, just because you made a 20-line change in your application? It doesn't make any sense. It muddles, infrastructure with your deployment unit. When does it make sense to deploy a new Docker instance? Well, when you've actually made a change to your infrastructure. You've changed your your JVM version. You've changed your application server version. You've changed your operating system version. Well, that's a reason to deploy a new Docker instance, not that you made a day-to-day, your developer made a day-to-day change. You'll also see microservices being heavily pushed with cloud, PaaS and SaaS, not SaaS, IaaS and PaaS. So the idea here is that, okay, if you're developing microservices, you must be using cloud and IaaS and PaaS. Well, the reality is that if you're developing really coarse-grained really fine-grained microservices, things that we saw in the Netflix diagram, yeah, you probably don't want to manage that type of infrastructure yourself, right? You probably, at that point, you do want somebody else, that to be somebody else's headache. So you do want to use a PaaS or IaaS in that case. But if you're not doing that, then the decision of whether to use cloud or not becomes less binary, right? It's a distinct concern. You could develop these practical microservices in-house, on your own infrastructure, or you could develop it on the cloud, or you could do both. Right? You could have a hybrid system. It's no different than the concerns you have in developing monoliths, for the most part. You'll also see a bunch of other tools that are out there that are being sort of co-sold with microservices. These are things like Eureka, RxJava, Hystrix. They're largely part of the Netflix OSS stack. This is basically, you saw that Netflix system. In the process of developing that system, they basically developed a whole set of APIs that they open sourced. Well, again, do you need these things? Well, yes, you need these things if you're developing microservices like Netflix is. If you're not, these things are overkill. They're just adding complexities to your tool chain and skill set that you don't really need, right? So you can use them. You can use them with Java EE if you like. You just have to be careful whether you actually need these things or not in the first place. Okay, so I'm slightly over time. I usually am in this talk. I'll summarize and give you some resources. I hope that will be valuable to you. So microservices have a long history. Honestly, none of these concepts are very new. I don't think they're honestly very different in practical terms with SOA. It's definitely a very valuable architectural technique. It's something that you need to understand and you need to have in your tool belt. But it's not necessarily something you'll apply universally. It's not a cure-all. It's not for every single application that you'll develop. You have to choose very carefully whether you need it or not, and you may not always need it. Okay, and even if you do need it, you don't need to apply it all at once. You may. My recommendation is to start with a monolith, but to keep microservices in mind and then adopt microservices as you actually need them. As you've hopefully seen, and you'll see when you dig into the code examples, vanilla Java EE goes a long way. It's a very capable platform for developing monoliths. It's a very capable platform for developing practical microservices. And in fact, when I mentioned in my previous slide things like Wildfly Swarm and Payara Micro and CoreMoloZ, those things are really nothing much more than supporting even very coarse-grained microservices. Fat jars and Hystrix and Docker and all that. Right? You can go whole hog with vanilla Java EE if you so wish. Right? You can go all the way to microservices and Nirvana if you actually have a legitimate use case for it. Okay, so I'll leave you today with a few resources. The first resource is by Martin Fowler. Martin Fowler and microservices is a bit of a strange story, so let me explain sort of this resource. So Martin Fowler's articles on microservices is probably one of the most widely read, okay, in terms of sort of entry-level material into microservices. When I started looking at this material, frankly, it worried me quite a bit. I actually respect Martin Fowler quite a bit, but it really worried me, the series of articles that he started with. A lot of these articles were very, very sort of unbalanced, gave an unbalanced view of microservices. They just talked about what the good part is of microservices, and it never bothered talking about, well, what are the downsides. So finally, I was very refreshed when he finally wrote an article, or a couple of articles, almost at the tail end of his series on microservices, on what could actually go wrong with microservices when you shouldn't consider them. So the article that I have listed here is actually one of those articles, and it's called Monolith First. Okay, it actually says why you should start with a monolith and why monoliths are good enough for most applications, and when you should start thinking about microservices. So I really believe this is the article you should start with, and then work yourself back to the rest of the articles by Martin Fowler. There's another article out there that I really like. It's about my remaining beef with Martin Fowler, in that Martin Fowler still does not acknowledge that microservices is really nothing much more than a variant of SOA, and these two things actually have much more in common. So I think this next article is also worth taking a look at. If you want to learn more about Java EE, the rest of the resources there are for you to take a look at Java EE. So I won't talk about those in great detail. Okay, so that's it for me for today. I'm going to go ahead and stop my screen share.
All right.
So hopefully you can see me. I'm sorry, it's a little bit 15 minutes. I get about 15 minutes above the hour limit.
No, that's fine. Typically, we actually have an hour and a half, so you're totally good.
Okay.
So, I mean, I probably have a couple questions for you, and I have a few other guys here in the room, and they might have a question or two. So, are you up for some questions? Or
Absolutely, yeah.
Okay. We'll try not to take too long, though. I guess the one question I have is like, and you might have covered this, but like, what are some of the signs that you should look for that you should start breaking apart an application?
There's a few. So the most obvious one is when you have a large number of developers, and it's very obvious from the start that it's going to be a large application. Mm-hmm. So I talked about the insurance system, right? I mean, whenever somebody is beginning to write an insurance system, it's very obvious that we're dealing with multi-million lines of code and probably close to 30 or 50 developers that will need to work on the system. That's an obvious sign where you need to break up the system and talk about developing subsystems that probably have something in the neighborhood of 10 or so developers working on them. So that's one big one. You have an application that is taking a very, very long time to deploy. Right? So you really do have half-hour deployments or an hour deployments. Right? That's a good use case for beginning to break up your monolithic application into smaller parts. That's another obvious red sign. You're having trouble scaling the application. Right? Mm-hmm. You've done horizontal scaling, and the horizontal scaling you've sort of reached the upper bound of that. But that's frankly very unlikely to happen. That's another case where you would want to think about maybe breaking up your application.
So, I mean, you mentioned team size as well. So, would you suggest that smaller teams it's riskier? Say, 3, 4, or 5 developers working on like a large monolithic application. Is there more risk involved to start breaking it apart, or would you say not?
3 to 5 applications is typically you probably don't have any need to break it up, right? If you have 3 to 5 developers and then they're working normal hours, right, to develop or maintain the application, it's a very clear indication that there's no need for microservices. It's probably a reasonably sized monolith.
Mm-hmm. Okay, Nate, did you have a question?
Yeah. Hey, thanks for the talk. So you're talking a little bit about containerless frameworks towards the end. I was curious if you've worked with anybody that's starting to move towards the cloud. Like AWS has their Lambda service, and all the other main cloud providers are following suit. And there's frameworks like serverless out there. Do you see any benefit to starting to break out smaller functions and execute them in an environment like that?
So in my mind, those are not necessarily. Those have nothing to do with monolith versus microservices. There's no reason why you shouldn't be able to deploy a reasonable monolith into an AWS, right? And so AWS you don't necessarily have to use those containerless frameworks. Amazon's cloud is perfectly capable of running, Glassfish or what have you, right? So you don't have to adopt those. You should only adopt those if they actually make sense. Have I seen anybody adopt them? Not as of yet. So I have seen a few people using Spring Boot, right? And honestly, those cases is questionable in my mind. A lot of them are startups. They started doing it because it's the new hotness thing to do, rather than, in my mind, really thinking very clearly whether they actually need this or not.
Okay. Thanks.
Do you have anything else?
Yeah, one other small question, I guess. You were talking about kind of having like the fat jars and the downsides to that. Like, what were the major cons to using that you mentioned? Is it mainly the size and like just copying them around and managing that? Because I would think the startup time would be comparable to running inside of a container in terms of startup time.
So there's a number of them.
Or is that another reason as well?
So there's a number of them. So number one is that configuration complexity. So when you're writing a Java EE application, because you have everything in the runtime already, you configure absolutely nothing, right? So you know what APIs that you're writing against. You simply write against those APIs, and you have no configuration. There's nothing to configure. So in order to write the fat jar approach, for example, if you compare Wildfly with Wildfly Swarm, well, in Wildfly Swarm, you've got to configure, all those APIs. You've got to tell Wildfly Swarm, these are the APIs I'm using. Your Maven configuration becomes more complex. Your application configuration becomes more complex. They are larger deployment units. Again, refactoring the same application to run between Wildfly and Wildfly Swarm. Running against Wildfly, you're talking about probably something under 5 megabytes, and the same application running in Wildfly Swarm, suddenly your unit of deployment is becoming 30 to 50 megabytes or more. That takes a longer time to deploy. In terms of deployment startup time, there's definitely a difference because as you saw, I was deploying my application against a running Glassfish instance. So Glassfish is already up and running. All of the runtime is already initialized. All I'm really doing is deploying the application. So when you are talking about a fat jar, well, guess what? You're not just starting up your application. You're starting up your application and its corresponding runtime. The HTTP server, all of the database services. If you have monitoring services, all of that has to start up. That all adds up to startup time versus simply deploying the application on an already initialized runtime. As I said, for administrators, it becomes more difficult. You suddenly don't know what is this thing that was deployed. What version of the runtime am I talking about? How do I? What is the login? What is the login that I need to manage? What are the database and resources that are deployed? How is this thing tuned? You suddenly don't know because you're changing from deployment. It can change from one deployment to the other. Versus, if you have a predetermined runtime, well, you're controlling that runtime. You know what's deployed, how it's configured. Those things are in parts of infrastructure that are not changing from one deployment to the other.
Okay. Yep. Thanks.
Okay. Do you have anything, Brian? No questions. All right. So I know you mentioned Spring Boot a little bit. You want to elaborate on that at all? I know you said you've seen some people using it. What were some of the downsides or even upsides or whatever trade-offs there to using some? I mean, I know we're talking about fat jars and things like that, but was there any other specific trade-offs that you saw as negative or?
So I'll tell you about Spring Boot plus or minus. So one of the things I've always disliked about Spring is the configuration complexity. Mm-hmm. Whenever you're starting a Spring application as opposed to a Java EE application, you've got to do a whole bunch of upfront configuration to bootstrap your project. And the one thing that Spring Boot does is to try to reduce that bootstrap time. Because what Spring Boot does is that it allows you to essentially follow recipes to say, okay, these are the things I want. Mm-hmm. Sort of automatically configure these things for me. Right, so they're very similar to what Java EE does. In Java EE, everything is already pre-configured. Spring Boot, it does the similar thing. It takes away that Spring configuration overhead. The problem with doing that is Spring is not Java EE. Right? Spring is designed to be very, very configurable, and there's a whole bunch of transitive dependencies that Spring has. Yep. So while developing Spring Boot, by suddenly taking away all that configuration and automatically handling things like transitive Maven and jar dependencies, if that doesn't work for you, right? So if you run into any problems, let's say jar conflicts, or the configuration that Spring Boot is giving you is not quite what you want, and you got to reverse engineer Spring Boot to figure out what is Spring Boot doing and how do I make it do what I want it to do. Those are all downsides. Again, these things don't exist in Java EE because you don't have those options. You can't configure your runtime. The configuration is what it is. So yeah, those are the pros and cons that I've seen.
Okay. Thank you. Any other questions? Okay. So you'll post. I guess you'll post those links, or we can have access to those slides. I guess.
So I'll show you the slides right now.
Okay.
Let me share my screen once again. The slides are actually the most up-to-date version of the slides are always on my SlideShare account.
Okay.
So it's slideshare.net /Reza _ Rahman. And if you go to the SlideShares, here's the talk. Right? So this is the slides, and it's actually the PDF version of the slide. So you can download the PDF if you like. Download the PowerPoint if you like.
Okay.
There you have it. It's the URL for it is also relatively simple, but you don't need to remember it necessarily. It's slideshare.net Reza _ Rahman Java E -microservices.
Gotcha. All right, I think that's about it. I guess Karen, you're on there. You didn't have any. Did you have any questions, Karen? I've kind of forgot about you.
No, I'm good.
Okay. Well, thanks a lot, Reza.
Yeah, absolutely. Like I said, hopefully when things settle down, maybe I can try to come over there in person.
Yeah, that'd be awesome. We'll definitely keep you in mind for that. All right. Well, thanks a lot, and have a great evening.
Yeah, absolutely.
All right. Bye-bye.